When working with an individual value from a normally distributed population, we use the formula x bar minus mu over sigma. When working with a sample or a group and not a single individual, we use the formula x bar minus mu over sigma divided by the square root of n. So if it's a single individual, we use the top. When it's dealing with a group, we use the second one. So let's look at an example. When women were allowed to become pilots for fighter jets, engineers needed to redesign the ejection seats because they had been originally designed for men only. The ejection seats were designed for men weighing between 140 and 211 pounds, whereas women's weights are normally distributed with a mean of 143 pounds and a standard deviation of 29. So knowing all that, if one woman is randomly selected, find the probability that her weight is between 140 and 211 pounds. So like with all of them, we're going to find our mean and standard deviation first. So our mean is 143, and our standard deviation is 29. But now our x value, our x bar, is between two values. So we're going to say 140 is less than x bar, less than 211. And we're going to find two z-scores, one for 140 and one for 211. So z equals 140 minus 143 divided by 29, which gives us a z-score of negative 0.1. Now we're going to do it again for 211. So z equals 211 minus 143 over 29, which gives us a z-score of 2.34. And now we're going to find the area between these two values. So we're going to go to normal CDF, and our lower bound is going to be negative 0.1, and our upper is going to be 2.34. So bring up our calculator, and then we're going to go to second vars, normal CDF, and so negative 0.1, comma 2.34, which will give us a z-score of 0.5302. 0.5302. So the probability of selecting an individual woman randomly and having her weight be between 140 and 211 pounds, 0.5302. Now let's do it again, the exact same question, except we're going to select 36 women instead of just one. So again, our mu, 143, sigma, 29, still going to be between 140 and 211, but this time we have an n value of 36. So now we're going to go through again, find our z-score for 140 and for 211. So z equals 140 minus 143 divided by 29 over the square root of 36. And that's going to give us a z-score of negative 0.62. And then one more time, z equals 211 minus 143 over 29 divided by the square root of 36. And this will give us a z-score that is actually decently high, 14.07. It happens, you can have z-scores this high. Doesn't happen too often, but if you're unsure, always just double check your arithmetic and make sure it's right. In this case, it is. Now we're going to find the probability between these two z-scores. So, normal CDF, our lower bound being negative 0.62, and our upper being 14.07. So again, we're going to bring up our calculator and use the normal CDF function. So second in vars, number 2, negative 0.62, comma 14.07, close and enter, and we get 0.7324. So 0.7324. As a probability of selecting 36 women with their weights between 140 and 211 pounds. Now let's apply what we figured out. When redesigning the ejection seats to better accommodate women, which probability is more relevant? The result from part A or the result from part B? Now you got to think about this kind of logically. When you're in a fighter jet, when you're trying to sit down in it, how many people can sit in a seat? You can only one person at a time. So which probability is more relevant? Part A. And the reason why is because seats are occupied by an individual, not by a group. Seats are, that's how you spell it, occupied, move that out of the way since it's in the way, occupied by individual women, not groups of women.